Imagine standing on the roof of the world, 2,000 meters above the earth, where the air is thin, the wind is sharp, and the silence feels almost absolute. From this height, the human eye sees only a tapestry of blurred greens, browns, and grays. A forest becomes a carpet. A field becomes a patch of color. A living creature becomes nothing more than a moving dot. But high above the valley, a golden eagle sees something else. It does not simply see the forest. It sees the rabbit hiding in the grass. It sees the twitch of an ear. It sees the shape of the body beneath the stems. It sees the texture of life from the clouds. Distance is a wall. To the raptor, distance is only a variable. The target is acquired long before the prey understands it has been seen. This is not ordinary vision. This is the sniper's focus. Behind the golden iris of an eagle lies one of the most sophisticated optical systems ever built by evolution. Not metal. Not glass. Not digital sensors. Protein. Nerve. Blood. Bone. Light. A weapon guidance system grown inside the skull of a bird. To understand how extreme this vision is, we first have to understand our own limits. Humans are visual animals. But compared to raptors, our eyes are modest tools. In our skull, the eyes take up only a small portion of the head. In an eagle, the eyes are massive. They can be almost the same size as human eyes, even though the bird's body is far smaller. If humans had eyes built in the same proportion, they would be the size of oranges. The eagle's skull is designed around sight. It is not a brain with eyes attached. It is an optical platform built for hunting. The eye is not an accessory. It is the command center. But size is only the beginning. The real genius is the dual fovea system. In the human eye, we have one central point of sharp focus called the fovea. It is the tiny region of the retina where detail becomes clear. When you read a word, recognize a face, or focus on a single object, you are using that central fovea. Raptors go further. Many birds of prey have two foveae. One is used for forward binocular vision, giving them depth and precision when locking onto prey. The other is positioned for sideways viewing, acting like a built-in zoom lens for scanning the landscape. In simple terms, an eagle can watch the wide world and magnify the target at the same time. It is like having binoculars built into the eye while flying. A slight tilt of the head can shift the image into the deeper fovea. The bird locks onto a mouse, rabbit, fish, or smaller bird, and suddenly the world narrows. Background disappears. Noise disappears. There is only geometry, speed, distance, and the target. Absolute situational awareness. No distractions. No wasted focus. Then comes raw resolution. Imagine your eye as a camera sensor. The more pixels packed into the sensor, the sharper the image. Human vision is impressive, but the eagle takes the pixel count to another level. A human retina may contain around 200,000 photoreceptors per square millimeter in its area of sharpest vision. An eagle can have up to 1 million. That is roughly 5 times the optical density. Those. An animal at a great distance becomes a smudge, a vague movement, a blur at the edge of recognition. But to a raptor, that same target can appear sharp, separated, and readable. Where we see a green field, it sees blades of grass. Where we see motion, it sees posture. Where we see a dot, it sees a body. This is not simply better eyesight. It is a higher resolution reality. A hawk perched on a skyscraper can scan the street below and detect tiny movements that would be invisible to us. A falcon in flight can track another bird while moving at extreme speed. A golden eagle can survey a mountain valley and isolate a single weakness in the landscape. Every photon matters. Every movement is data. Every detail could mean survival. But a sniper needs more than magnification. It needs speed. This is where motion detection becomes terrifying. Humans experience motion as smooth when images pass at roughly 60 frames per second. Our brains stitch reality together at a rate that works well enough for walking, driving, and watching movies. But many birds process visual information faster than we do. Raptors may perceive motion at over 100 frames per second, sometimes even higher depending on the species and conditions. To a hawk. Our action movies might look like slow-moving slideshows. To a falcon. A fast human gesture may look delayed. To a bird of prey, time itself is sharper. This is called flicker fusion frequency, the point at which separate flashes of light appear as continuous motion. The higher the frequency, the more moments the brain can separate. Raptors do not just see the world in higher resolution. They may see it at a higher frame rate. They see the gaps between moments. And in the hunt, those gaps are everything. When a peregrine falcon dives from the sky, it can reach speeds above 300 kilometers per hour. To a human, that kind of motion would be chaos. Wind, blur, pressure, impact. But for the falcon, the approach is controlled. The eye is still feeding data to the brain. The brain is still calculating angle, distance, velocity, and timing. The talons are still receiving instructions. You cannot outrun a brain that processes time faster than you do. But at those speeds, the eye itself becomes vulnerable. Wind, dust, debris, and pressure could destroy vision in a fraction of a second. So raptors carry another piece of biological engineering, the nictitating membrane. The third eyelid. It moves horizontally across the eye like a translucent shield. It protects the surface, keeps it moist, and still allows the bird to see. Think of it as high-speed flight goggles. A peregrine entering a vertical dive does not have the luxury of blinking blindly. It must protect the eye without losing the target. The membrane sweeps across like a clear windshield, and the hunt continues. Moisture maintained. Debris blocked. Target locked. At 300 kilometers per hour. This is not a convenience. It is survival. The eye also needs structural support. Inside many bird eyes is a ring of tiny bones, called the sclerotic ring. This ring helps maintain the shape of the eye under the forces of flight, pressure, and impact. The eye must not deform. The image must not distort. The focus must not fail. Even the shape of the cornea matters. The curved front surface of the eye bends incoming light, helping create the sharpest possible image. In Raptors, this optical system is tuned like a high-end lens. Every surface, every fluid, every cell is part of the weapon. But light is not always helpful. Sometimes, light is the enemy. Glare from water, snow, or sunlit air can hide prey from ordinary eyes. Reflections turn rivers and lakes into mirrors. Bright sky washes detail away. Raptors fight this with natural filters. Inside their cone cells are oil droplets that can filter certain wavelengths of light, increase contrast, and sharpen color separation. These microscopic filters help reduce haze and glare, making prey stand out more clearly against the background. An osprey hovering above the water is not only watching a fish, it is calculating refraction. The fish is not exactly where it appears to be. Light bends when it passes through water. The osprey must correct for that distortion, then dive with precision. It strikes through the surface and emerges with the target in its talons. A clean hit. A living missile guided by optical mathematics. Some raptors can also use ultraviolet information. Kestrels, for example, are known for detecting UV reflective traces left by rodents. Those. A field may look empty. To the kestrel, it may contain glowing trails, chemical signs of where prey has traveled. The hunter is not just seeing animals. It is reading the history of the ground. A hidden world becomes visible. Vision is not passive for these birds. It is prediction. It is strategy. It is action before action. The brain supports this system with enormous visual processing power. Birds have large optic lobes. And for many species, vision dominates sensory life. The eye gathers data. The brain processes it. And the body responds almost instantly. In a goshawk flying through dense forest, this becomes almost impossible to believe. Branches flash past. Gaps open and close. The bird twists through the trees at high speed, calculating space in milliseconds. There is no hesitation in that eye. Only the gap. Only the path. only the next opening. This is focus as a shield. The raptor survives because it does not divide itself. In the moment of the hunt, there is no anxiety, no distraction, no wasted thought. The entire body becomes one line of intention. Eye, brain, wing, talon, impact. Different raptors specialize in different worlds. The eagle rules distance. The falcon rules speed. The owl rules darkness. The osprey rules water. The goshawk rules the forest. The secretary bird rules the ground. But all of them are connected by the same principal vision as power. When night falls, the owl takes the stage. Its eyes are not built like the eagle's. They are tubular, designed to gather faint light in darkness. The owl sacrifices eye movement for sensitivity, then solves the problem with an extraordinary neck that can rotate far enough to scan the world around it. Nature always finds a workaround. Every design has a trade-off. Every weakness creates a new adaptation. This is the genius of evolution. It does not build perfect creatures. It builds precise creatures, each shaped by the problems they must solve. And the raptor's problem is ancient: find the prey before the prey knows it has been found. Over millions of years, the arms race continued. Prey became faster, more hidden, more alert. Predators became sharper, faster, more precise. Generation after generation, the eye improved. More receptors, better focus, faster processing, stronger protection, clearer contrast. The result is not just an animal. It is an optical masterpiece. When you look into the eye of a falcon, you are not looking at a simple bird. You are looking at an alien perspective. It sees movement you miss. It sees detail beyond your range. It sees time with a sharper edge. It does not simply watch the world. It measures it. A raptor flying above the mountains lives inside a grid of invisible calculations: wind, light, distance, heat, shadow, movement, opportunity. Every flight is a series of equations solved in real time. No computer in the sky. No external camera. No digital zoom. Just biology refined by hunger, danger, and time. This is why humans study these eyes. We build drones, cameras, sensors, and targeting systems inspired by the same principles. But we are still students of the master. Long before we invented high-definition lenses, nature had already grown them. To see like an eagle is to see the world in high-definition reality. Not just clearer, more complete, more immediate, more unforgiving. The target is always out there. The signal is always waiting. The detail is always hidden inside the distance. The lesson of the raptor's eye is not only about hunting, it is about attention. It reminds us what focus can become when it is total. In a distracted world, the raptor offers a brutal kind of wisdom. If everything matters, nothing is sharp. But when the target is clear, the entire world reorganizes around it. The eagle does not waste focus. The falcon does not argue with speed. The hawk does not complain about distance. They look. They lock. They move. As the sun sets over the mountain, the light fades, but the focus remains. Somewhere above the valley, a silent shape circles in the cold air. Below, the field seems empty. But the hunter knows better. A twitch in the grass, a shift in shadow, a single detail in a world of noise. That is all it takes. The hunt never truly ends. Stay sharp.